body physics simulation with OpenGL and C++. The best part, the code is surprisingly brief and easy to understand thanks to AI. Yeah, I used Bing. I used Bing to generate the main structure of the physics simulation, which makes the code streamlined and straightforward, perfect for beginners, and easy to modify. So we'll talk about that. This is relatively quick here, I guess. First, we define variables for position, velocity, and dampening. And we'll go into here. Line 562 is the actual definition or the initialization. But here are the variables in the background star physics class. Excuse me. Position, velocity, mass, radius. Keeping track of the index for some of the variables, and dampening. And then we'll go down to line 562. So this is the initialization of the physics right here. So we have all of these soft body points. It creates the point right here. And then we're just filling in the position, the velocity. This is based on the stars that I've just made. This is the mass here between 0 and 1.0 is a random mass, and then this is the radius of the stars, so I'm going with the size, and we're shrinking it down to match the size of the points for OpenGL. This is the index into the stars, because we're actually going to keep track of what we're drawing versus what OpenGL is seeing, just the stuff we're going to draw. The CPU is actually manipulating the physics in this case, so we'll update each of the drawn stars physics behind the scenes. And then there's the dampening. We initialize to a random value between, it's like 0.05 or whatever. So, and then we just add them in, and then, let's see, I'm following a script here, so. Okay, the constructor handles initial values for position, velocity, mass, and dampening with just a few lines of code, as we just saw. This setup means we're ready to dive right into the physics. Okay. So, the AI-generated code includes a small effective gravity calculation, a dampening factor to reduce speed over time, and this keeps the objects moving naturally but slows them gradually. I'll show you that in just a second because it's right here. Lines 52 through 67, which we'll go back up to here. 52 through 67. This is the entirety of the apply physics function. This is it right here. So I showed this off in a previous video, but I'm kind of using a little AI to shrink down the video to make it a little bit easier to digest. So we start with gravity affecting the mass related to the size, of course. Bounce with some energy loss. So this is the vertical. I'm only affecting the vertical on the energy loss. We are drifting either way with the X drift. So kind of back and forth, very, very slight drift, not very much at all. So. And then here's the collision here too, as we can see, based on the distance between the points, which, because these are all points and they're drawn as a circle, we can just compare the radiuses, and the cumulative radius, one radius plus the other, if they're within that distance, then that's how we can tell it. See the position here, and then the cumulative radius is right here. So the minimum distance is one radius versus the other radius as we're cycling through all the points here. So when they get too close, we reverse the velocity to create a bounce effect. Okay, so that is right down here. If they get too close, then the temporary velocity is calculated. The other velocity, the new velocity for the y is calculated, and the temp vel gets updated to the velocity there. And then they're both dampened, because we don't want them to be jarring and running around crazy like that. So rendering using OpenGL, we render the objects and immediately see the effects of gravity, damping, and collisions. Minor tweaks in mass velocity make it easy to see how AI has optimized these calculations. So you can also just see how it works really quick like right in here. And in this case, what I've done is I've chosen a random points every 0.1 second, so 10 every second that gets chosen, and then respawn right at the top here, and they just fall right into place. That way there's a little bit more jarring moving around that we would not otherwise see. That's why I've done that. So let's continue on while that shows. Does that show in the corner? I should have had that running the whole time, but that's fine. Okay, so using OpenGL, render the objects immediately see. Okay, so now we'll go on. To make collisions look more natural, we add a small energy loss to each bounce, which I just showed. We can show it again. It's right down here. The velocity is multiplied by 0.9, and the other velocity of the collision is also multiplied by 0.9. So the collisions will eventually, in a relatively few frames, be nothing, be down to essentially zero. So that's quite nice. All right, this is AI generated code setting up a soft body physics simulation. Very simple, very effective. I liked it because the code was clear and minimal and yet produces a realistic effect. I was super surprised with this. In the upcoming videos, we could add features like lighting or more complex interactions. Let me know by leaving a comment in the video if you're interested. And also, if this quick, easy tutorial was helpful to watch, like, subscribe, and comment. And thanks very much.